have Steve invited me to talk here, I kind of asked him, hey, do you want me to talk about my research, or do you want me to give kind of a broader industry talk? I was like, you know what? And I said, you know what? Let's go with a sort of big picture industry talk, and that's what I will do. It's my pleasure. So I'll talk about several topics that are close to my heart. Deliberately, I decided not to use slides. I actually have slides in front of me. And I thought, should I show those slides? And then I realized that no, slides are evil. They make people concentrate on the slides and not on the talk. So there will be no slides, but I will reveal the title, Some Observations on Platforms, Frictions, and Classical Economics. So it's a big picture. So let me start with the obvious question. What do those three platforms have in common? Rideshare platforms, public clouds, and Mechanical Turk. Well, they have a lot of things in common, of course. But there are a couple of things that I kind of want to point out that I think are interesting. So first of all three of them reduce frictions. And they enable higher utilization of resources. That's what they do. And all three create homogeneous goods at the place where previously those goods were not quite as homogeneous. So let me explain what I mean. So let me start with public cloud. So as a first order approximation, and as I will later tell you, that approximation is not such a great approximation, but it's not a terrible one. Public cloud turns compute into a commodity. So of course, CPU, the cores were a commodity more or less for a long time, but there's a difference. CPU is a stock. You buy CPU, you put it under your desk, and that's a stock. And that stock is very much illiquid. It's very, very rare for me to knock at your door or your proverbial door and say, hey, it looks like your company has this 200 CPUs sitting under your desks not being used that much. Why won't I take those for a week or so, or for an hour or so? So that's not a conversation we can have. CPU is not liquid. The flow is not liquid. And of course, public cloud makes it liquid. CPU provides a stream of services that could be easily shifted around, so that flow becomes commoditized when it wasn't before. So of course, that movement from flow, from a stock being more or less a commodity, to flow that the stock generates becoming a commodity is pretty common. So look at WeWork. That's kind of what they do too, right? But with real estate. Look at modern rental markets that evolved. Like, the rental market today is a relatively well-functioning market. We have standard agreements. We have relatively low transaction costs. So, renting an apartment 200 years ago was probably a more difficult ordeal. And so that's just general part of development of financial systems, of course. So now let's look at rideshare. So what is it that rideshare turns into a commodity? And that, by the way, is not a rhetorical question. It's actually a non-obvious question. Does it turn anything into a commodity that wasn't a commodity before? What does it turn into a commodity? Any suggestions? Does rideshare turn anything into a commodity? Let's do a show of hands. Who thinks that it really doesn't relative to whatever taxi and limo industry that existed before? So who thinks that it does? So what does it turn into a commodity? What is it that became a commodity that wasn't a commodity before?
Cars.
Okay, but the cars were a commodity. I mean, I can buy a car, and rides were in some sense the same kind of commodity. I can call up Before Uber, I can call up a limo company and I could say, I would like a ride from A to B at this hour, and they would say, yes, sir, and they would send a black car for me, which was very, very popular in New York, starting from like 1980s, way before Uber. So that it's not entirely obvious how it got commoditized. So what else is being commoditized here? Huh?
My free time.
Your free time is commoditized. And who are you? A researcher or like?
It's a potential driver.
Yes, exactly. So what is really being commoditized here is driver's time, and driver's time as kind of not driver as a stock, right? So all of us have jobs, and there's a relatively fluid labor market, right? You apply for a job, you kind of know what kind of job you can get. You get more or less what you think you deserve if your expectations are realistic. So we have a relatively fluid market for labor. So just like we have always had a relatively fluid market for cores, for CPUs. But here the story becomes a little bit different. So when you get a job, you basically sell your labor, but now that flow that your labor generates is no longer a commodity. You are not, unless you work for a temp agency or something, you're really not up for rent. You work somewhere, it's a relatively sticky relationship. Your wage is not renegotiated every week, right? So that's what changes with rideshare. You turn labor into flow in the same way in which public cloud turns cores into flow that could be kind of seamlessly traded. And you as a worker, you can start working anytime, and you just keep selling that flow of your labor services essentially at something that looks like a spot market, right? You are working at a day when demand is unusually high, the price is surging, you make double the money. Last time there was a snowstorm and in Seattle, the Uber price was surging something like, I think, over 2x. And I asked an Uber driver, how are you doing? And he said, well, I made triple the money relative to usual. Fewer drivers on the road, double the prices, lots of demand for passengers. It's a good day when there's a snowstorm, at least sometimes, right? So that's a different story. You have basically a spot market for labor. So by the way, I think that's something that makes rideshare quite interesting and unusual, because that kind of spot market for turning capital goods into flow when you rent them has a long history, right? Real estate, most businesses that operated 150 years ago, almost all of them owned their premises. They owned the real estate they used. Today, go to Telegraph Avenue, go to University Avenue, ask those businesses, do you own the real estate that you're using to operate the business? Usually the answer would be no. In fact, it's basically the same family who owns most of the commercial real estate on Solana Avenue, which is one of the busiest business streets in Berkeley, right? So that's a different model. So it is common to turn those capital goods into flow, or at least not uncommon. But turning labor into this kind of flow is actually quite unusual. Most people have jobs. The jobs have a certain wage, and that wage doesn't fluctuate from day to day, from year to year. Wage is kind of it's actually almost impossible to lower the wage. It's very, very rare to lower the wage. You can lower other parts of compensation, like bonuses, but there's some lower bound that's relatively high. So that's what really makes rideshare quite different and quite interesting. You have this almost a dream of a classical economist, this kind of general equilibrium where labor becomes more of a true commodity, for better and for worse. And of course, it's on all of our minds because of recent legislation in California that basically makes it harder for ride-sharing companies to classify drivers as contractors. So definitely, in some sense, those platforms, be it cloud, be it Mechanical Turk, be it rideshare, they bring us a step closer to something that resembles a general equilibrium economy, where you can kind of seamlessly reallocate resources, which could be a good thing, but it's also not without serious drawbacks. But before we talk about kind of the good and the bad things about commodification, let's kind of go down a little bit down the memory lane, let's look at economic history a little bit. So first of all, there is nothing new about creating commodities. In fact, the entire history of modern economics, of modern economy, not modern economics, is a history of commodification. So many things that today we think of as commodities, pork belly, grain, oil barrels, apples, whatnot, those are the things that today are very much commodities. You open up the Wall Street Journal, you see the price for those commodities. They're liquid commodities. And yet, and I don't know how many people here are kind of students of market design and how many people are coming from kind of different disciplines and areas, but if you are a student of market design, you almost certainly or probably know that those things weren't always commodities. They very much weren't, because not all barrels of oil are created equal. Not all apples are created equal. And people knew it very, very well. 200 years ago, when you wanted to buy apples, all apples were different. All apple trees were different. Some were really sour, some were sweet. They were all different, and different sizes, different everything, different number of worms in them, right? So you look at apples, you see what you get, you haggle for the right price given the quality. So how could you talk about apples being a commodity when they're so different in quality? So similarly with grain, different grains have different density. It's the same plant, but depending on the soil, depending on many factors, on the water availability, it would have different density, different size, different many things. Different percentage of different humidity, and so on and so forth, right? So again, that matters, that influences the price. And of course with oil is very much not a commodity, because if you look at Saudi oil versus Far Eastern oil, they're really different, very, very different oils. They actually have very different chemical compositions, and that really influences kind of the process of refining that oil into something else. But people said, look, let's figure out some kind of standard where we'll have a canonical commodity. Here's a standard apple. Here's a standard barrel of oil. And then whenever something is slightly non-standard, we'll have a complex table for adjustments. So this oil is different from canonical oil by this much. We know that it's 12% less valuable because of this and this. So you create a certain system of standardization and adjustment. So the reason that all those things that are commodities today is because humans made them so. Because we created a fictional unit of standard oil, no pun intended, and then we kind of learn to convert actual oil into those standard units. And by the way, for example, one of the things that makes a big difference for oil is where it is. because transportation is expensive. So standard unit of oil is, I believe, in there's a particular point where standard unit of oil is located, which I think in Louisiana, but I'm not sure. Right? So, so it's a process. So what happened when we have this commoditization of things? We know that the prices of commodities are notoriously volatile. In fact, for example, if you look at coffee prices, they're crazy. They could change several times depending on the harvest, as they should, right? Because you have relatively inelastic demand, so you have an enormous volatility. It's common for commodities to be very volatile for kind of fairly obvious intuitive reasons. So the first question is, okay, so commodities are notoriously volatile, but is it something intrinsic about those goods, or are things becoming more volatile because they become commodities? And you can very easily write a theoretical model that would imply that when you turn something into a commodity, the price of that has to become more volatile. So you can also write the theoretical model where it doesn't happen, but it would be a little harder. So the intuition is very simple. Why would things become more volatile when they are when they become commodities? Let's say apples are not a commodity. You know a couple of farmers, you think this guy's good, this guy is really good, this guy's okay. You have a pre-existing relationship with them. You know what their apples are. You come, you haggle, you negotiate the price, and you know, the guy with, you know, those expensive apples, you can tell him, hey, you know, why won't you sell me apples cheaper this year? And I say, well, why? You know, why should I sell you cheaper this year? Oh, it's plenty of apples this year. Oh, you tell me every year that there are plenty of apples this year. That's what you always tell me. You always try to get lower price from me. But look, my apples are good. Sure, there may be some other bad apples that are not very good, but good luck finding the same quality apple as mine. And you're like, well, you know, that's complicated. Actually, the search cost here is really high. It's complicated. And again, we write that contract not at the time when I can examine your apples, right? So someone else could promise me excellent apples, but who knows what they will deliver, right? How we're even going to write that contract. So there's not that much kind of, there's a very high search cost, and that would probably create huge anchoring from kind of previous year prices. So on the other hand, when it's commodity, it becomes extremely clear. Your apples are 10% more valuable than canonical apples. We have this totally fluent market. Canonical apples this year, there's just so many of them. People couldn't eat that much. Canonical apples this year are 5 times cheaper than last year. So what are you going to get for your apples? Well, not much, right? So or vice versa, right? There's shortage of apples. The price of canonical apple is super high. My apple is almost as good as canonical apple. It also should be super high. So, so theoretically, you should expect higher volatility. So first, I think that it would be wonderful if there were an economic historian. So I'm not aware of any papers that actually compare volatility of goods before and after commodification. So I have a conjecture that it has to increase. I know commodities are very volatile, but I don't know of any papers that actually document it empirically. It would be very interesting if someone were to look at commodification and see if it actually led to significant increase in price volatility. And if it did, that tells you something about what to expect in other markets where we create commodification. And one of them that seems most interesting from this point of view would be rideshare. And the reason that I think rideshare would be quite interesting from this point of view is that here what's being commodified is human labor. And that, of course, unskilled human labor, and relatively unskilled. And that, of course, has huge ramifications for, well, for people who work those jobs. And also for the society, because, you know, to some extent, Uber and Lyft are serving as, among other things, nation's employer of last resort. They are the nation's unemployment insurance in some sense. And I think they're quite useful for absorbing idiosyncratic shocks in the labor market, right? So if there's a person who just randomly lost his job every year, randomly exactly 100 people lose a job, they search for jobs, they need a job kind of in the meantime, rideshare comes to the rescue in some sense. And that's great. That really helps to absorb idiosyncratic shocks. And in some sense, it's a huge efficiency gain there. But there's something else going on. There are also, as we know very well, there are systematic shocks in the labor market. There are recessions when you have significant unemployment. So there, when there's a systematic shock, would we experience something similar in terms of kind of the price of labor as we experience in other commodity markets, wild swings? And if we do experience that, first of all, do current Uber and Lyft drivers who do it full time, are they anticipating that, hey, come recession, the market equilibrium price of whatever they would be earning could drop dramatically? In fact, the market equilibrium that's currently way above minimum wage for most areas may go way below minimum wage. What would happen then? So that's certainly something that I think is concerning. And in fact, if we look at commodity markets, there are some commodity markets where because of that volatility, we simply have, large players writing essentially insurance contracts, right? Or large players just swallowing the risk, right? If you're Starbucks, you can do a lot of things to risk manage, and you're pretty well positioned to swallow that risk. You also see other markets like US farmers, they're exposed to this enormous risk in commodity prices. And there you have really a government regulation system with USDA doing a lot to soften those blows. And I realize now I'm starting to sound like a macroeconomist, which I'm not, but that's what being a chief economist makes me, right? Like most of the time I deal with micro issues, but sometimes like those macro issues come my way, and I find them interesting and important. So that makes me think that we really need to, as a profession, as economists, as market designers, we really need to think more carefully about the public policy problem around kind of how we as a society could intelligently and efficiently deal with this issue of possible great volatility of ride-sharing drivers in time of recessions, where you can easily imagine demand for ride-share going down a bit because of recession, but then the supply of drivers going way up because there are people who couldn't make car payments, they're desperate, they want to drive, but what does it do to the price? It just hits the bottom. You can say, well, it's okay, it's a market equilibrium price, but at the same time, hey, commodification brings us closer to general equilibrium. We as economists, we love general equilibrium because it gets us efficient outcome. But guess what? In general equilibrium, there are Arrow-Debreu securities, meaning that there's a perfect insurance market implied in general equilibrium. But there's no perfect insurance market for ride-sharing drivers. Well, maybe we need to create one. Are the laws that are currently being passed that reclassify drivers, that require reclassifying drivers as employees, is that kind of a great solution? Well, I can certainly see why people may like that solution. I can also see why people may dislike that solution, because first of all, it takes away that potential benefit of basically kind of Uber being the employer of last resort, where in the absence of macroeconomic shocks, it really provides people valuable insurance against idiosyncratic shocks that they're experiencing. So that could be a problem. It could just in general make things more cumbersome and less dynamic. Also, it's not clear that it would help it's not clear how it would solve the problem of kind of declining of equilibrium wage during recession, right? So it wouldn't be a good thing if you have a ride-sharing company during recession where market equilibrium price becoming much lower, just firing all the workers and hiring new ones at much lower price. So it's not clear that those laws would actually solve this problem of price volatility. But certainly I expect that some institution, governmental or private, would emerge to somehow solve this problem. So of course, you have somewhat of similar problems with public cloud. But I will talk, but of course it's much less severe because with public cloud you're not dealing with kind of low-skilled poor people who could poorly absorb shocks, right? So with public cloud, that part is not much of a concern because the companies that provide the service are some of the largest companies, right? It's Amazon, it's Microsoft, it's Google. So those are the companies that know how to think about risk, that know how to insure themselves, and so on and so forth. They're also much less subject to those price fluctuations simply because cloud is actually not a commodity. The switching cost between clouds is quite high, at least at this time. There are some tools that kind of try to make it easier for consumers to switch between clouds, but it's not easy. But let me talk a little bit about kind of the cloud and draw a little bit of a parallel there with ride sharing. So really cloud, you can think of cloud as one big sausage of CPU resources. You need this much, here's your piece. You need this much, here's your piece. You just deal with it like with any other commodity. So it's a really helpful model, and I'm going to indulge myself and you into thinking about cloud in this way. This model is actually quite deeply flawed. Before I joined Microsoft, I was chief economist for Google Cloud. So once you kind of look at the sausage from inside of the sausage, you realize it ain't a sausage. So I'll talk about why it ain't a sausage in like 5 minutes. But for now, let's pretend that it's a sausage. And it's a really useful analogy, just like kind of a round horse in physics. So let's imagine that cloud is simply compute resource and it's completely homogeneous and everybody needs a certain amount and everybody has fluctuating demands. So then if you take that view of the cloud, then of course it's dramatic efficiency improvement for very obvious reason, right? If you couldn't use public cloud, you would have to have your own stock of that resource. But since your demand actually fluctuates, you will have to basically have quite a bit of that. And you would also have to keep it kind of on your premises, which would be more expensive because your premises weren't specifically built to be super efficient for hosting those CPU resources. So there's kind of a clear efficiency benefit from public cloud. When you talk to businesses about why they want to use public cloud, they say, well, agility matters for us. What really matters for us if there is kind of a burst, if we need a lot more compute resources, in 2 weeks, just being able to basically do nothing and have more of those resources, that's super valuable. So this agility, the word agility is very popular among cloud buyers, and that is why it's very popular among cloud sellers, because that's what cloud buyers want. So that makes sense. That's where value comes from. But then there's a question, okay, so what's the right way of selling that resource? And, I'm basically a market designer and an auction theorist. So my first instinct is to think about the world as an auction, even when it's not. Even if we are talking about, rideshare driver for whom there is no auction, it's very useful to think about it as an auction. So let's think a little bit about auction equilibrium price for cloud. Well, you would have, let's say you have a certain amount of CPU. So it's a big sausage, but it's not infinite. That's the one you have. So then you have certain demand at any point in time. So the efficient thing to do to simply allocate everything you have to, so the efficient thing is allocate everything you have to the highest value buyers and set reserve price. Efficient reserve price would be equal to your marginal cost. By the way, if you're an economist, your first guess is that marginal cost of cloud is actually 0 because you already bought CPUs, so might as well use them. That is actually not quite correct. Marginal cost is actually not 0. It's not 0 because cloud takes electricity. So if I switched off the CPU, I save some money. The savings are actually non-negligible. It's somewhere comparable to like 10% of the cost of compute is electricity. It's a rough ballpark. It could be more, it could be less, but that's like a rough ballpark. So it's not negligible, but it's quite low, right? So, well, would it be a reasonable thing to do to basically run an auction with a reserve price, and everybody who bids high enough gets the resource, and everybody who doesn't get a resource? Seems perfectly sensible, right? Except that nobody does it. That's not how Google sells cloud, that's not how AWS sells cloud, and that's not how Azure sells cloud. And those are kind of the three major cloud providers. AWS has the biggest market share, and Azure is the second, and the second player in the space. No, none of us do that. There's some small part of inventory that is sold using something resembling an auction to some extent, but the bulk of what's being sold is not being sold via an auction. And if you think about it, the reason is pretty obvious. You kind of couldn't really sell it as an auction, and here's why. Remember, there are big switching costs between clouds. So when you come to Azure, or when you come to AWS, or when you come to Google, you pretty much commit to using that cloud. You couldn't just flip a switch and 5 minutes later go to another cloud. In fact, it would be quite a significant investment to move. With some exceptions. And you certainly couldn't move on 1 hour notice. So now let's imagine that it was all sold via an auction. Could you see what could go wrong? Well, demand for cloud is pretty inelastic. People who buy compute typically are large businesses for whom the cost of compute in most cases is a small part of the cost, right? You know, when you're a Ford Motor Company, you're a huge consumer of cloud. When you're Walmart, you might be a huge consumer of cloud, but it's still a very small part of your overall revenue. And of course, it's a critical one. So no matter what it costs, you're not going to just walk away and say, hey, I'm going to use less cloud. So on the demand side, there's very little elasticity. There's some on the margin, but not much. So that means that if you were to simply rely on an auction, if there's sufficient capacity, then the price would always be pretty much price of electricity, the reserve price. And then, of course, the cloud provider would never be able to recover its fixed costs. So that ain't going to work. Nobody would want to be in this business as a cloud provider, right? So you don't want to run an auction with kind of ample capacity, with efficient level of capacity, and monetize it this way. So in order to make money, in order to just recover your cost, not even make a profit, just recover your cost, you would have to have some instances, if you're running an auction, you'll have to have some instances where there's a shortage of cloud capacity. And that's the times, those spikes, those once a year, once a month events where demand is unusually high, that's where you would be making all your money. But that, of course, would create terrible incentives for a cloud provider because they say, oh, Just have less capacity and we'll make more money. That's brilliant. Well, as a customer, would you like to buy a service like that? No, it seems like a terrible idea. The customer would say, well, wait a second, so I will be paying like basically almost zero all the time, and then I would be paying through the nose, maybe, 100 times, 1,000 times the average cost, because that would be only during the time of the shortage. So that would not be a healthy market. That would not be a good market. By the way, think about the electricity market. It has a lot of commonalities with this, right? There are some similar problems, but there are also some big differences, particularly with electricity. Kind of a bulk of electricity is consumed by consumers, by people like you and me who don't think much about it, and who are consumers. And of course, cloud is mostly consumed by businesses and enterprises. So it's different in this respect quite significantly. So basically, to make a long story short, I hope I convinced you, or at least explained to you, why we just don't see an auction for cloud capacity as a dominant model. It would create enormous risk for consumers. The consumers are here enterprises who would simply say, we don't want that. We would rather just be safe and have our private data center where things are totally predictable. We bought the cores and we're good. There's no price fluctuation. And it also doesn't create, you don't want to create terrible incentives for cloud providers. You can make lots of money by basically holding up your customers. So as a result, vast majority of cloud consumers basically buy cloud services at pre-negotiated prices that are stable, that are basically fixed and flat and don't change much. Basically that there's an understanding that they basically never go up, right? So in theory they could, of course, it might happen if there's like some big shortage, if there's some geopolitical event that creates huge shortage for RAM or for cores. There was a shortage of RAM in the past, but the list price of RAM was not raised. Maybe discounts that are given out during that time were a little lower than usual. All the old customers kept the same price they were getting before. Maybe new customers were getting a little bit less of a discount. But that's how the bulk of cloud is being sold. And then, of course, there's a very interesting question of how do you sell the leftover, the unused inventory without cannibalizing the rest of the market. And that's a really interesting question. That's one of the questions that my team works on. So now that I kind of gave you a big picture kind of general equilibrium economics super simplified story, now let me add a little bit of color of what the cloud market really is and what are the kind of first order and second order things that we wrestle with day in and day out. So some of the things that economists do for cloud, and my team spends probably at least a third of our cycles is devoted to working with Azure because it's such a complex and interesting and important market for us. So one of the things is capacity planning. And there are really interesting capacity planning issues there. So for example, to do it right, you have to think in terms of real options. You have to think, okay, we need to make sure that there's enough capacity for all our customers. So you have a certain demand forecast. Then I say, oh, wait a second, but what's the time horizon? What does it mean to have enough capacity? Because if I can predict today that there would be a spike in a month, well, if I can increase the capacity in a month so that I can meet it a month later, then it's fine, right? But then you say, oh, but there are different types of investments here. So for example, just buying cores may take relatively little time. You may be able to get the cores from the manufacturer as a consumer, you can go to Best Buy and buy a bunch of CPUs. As an enterprise, you actually couldn't do it because your orders are too big, so the manufacturer may not have enough in stock. But there's a relatively short lag time, right? If you have, say, 90 days, you can be pretty confident that you can buy enough cores. You have 90 days, you can be pretty confident you can buy enough RAM. Much less time may be sufficient, right? 30 days may be enough most of the time. On the other hand, you need to put those cores somewhere, and you need electricity to power them. So it turns out that data centers consume so much power that you couldn't just plug it into an electrical outlet. You don't plug in a data center in an electrical outlet. A major data center is a thing the size of a football field that consumes more electricity than the entire city of Berkeley. So you couldn't just plug it into an electrical outlet and get enough electricity to power it. So building a new data center, one of the kind of bottleneck that could take like a year or more is making sure that there is enough electricity there. You may have to build a power plant right there. So this electricity provisioning has a very, very long cycle, right? And so on and so forth. So you have different type of things you need to buy in order to provide cloud. All of them have different time window, and of course you have to have an intelligent forecast, and so on and so forth. So now let's go back to the sausage model. Is cloud really a sausage? Well, it actually isn't at all. The number of just a minute. So the number of products that cloud providers offer is not just in tens of thousands. I think it's more like closer to 100,000. So there are lots and lots of different products, and that's because there are different types of VMs. There's different hardware, there's different RAM, different network, like network configurations, and so on and so forth. So there's a lot of degrees of freedom there. And on top of that, there are lots of different locations, and they matter too. And for some customers, they don't matter. For example, if I'm doing scientific compute, I can run it in Japan, I can run it in California. It doesn't matter because the delay from running it in Japan would be significantly less than a second, so no big deal. On the other hand, if I'm running a real-time gaming service, that delay really matters, and you really want to have that data center that's nearby. So that's, again, another level of complexity, and kind of this customers are not homogeneous. For some, certain aspects matters, for some they don't. And that's why Microsoft has lots of small data centers. As you imagine, law of large numbers doesn't work there as well. So there's a higher cost factor. But it could be valuable for customers who need low latency, and so on and so forth. So I have 3 minutes left, and I think there are 2 questions. So let me try to take those questions. But before that, I would like to conclude. And the conclusion is, we are even interesting times, and there are a lot of interesting things to think about, both in theory and in practice, and I can try to give you the taste for both. Thank you, and let's go to the questions.
So my question was, is there a significant difference between a spot market and the actual market, the big one, in terms of whether we can run an auction or not, or whether we should run an auction or not?
So I'm not sure I understand the question, because to some extent, spot market is more or less by definition kind of an auction, and sort of.
Are there people that are competing for the CPU over the spot instances, or each person is just have a reserve price that should be above that? I think if I go to the spot instance of Azure right now, I can just pay the current price and I get the resource for the next hour.
That's right. That's right. So I think what you're asking. So let me make sure I understand your question. So I think you're saying, look, so there's some unsold inventory that's somehow being utilized. So Google has preemptible instances. Amazon used to have spot. I think now they call it something else, and it's less of an explicit auction. So the question is how far are those things from being a real auction? Is that?
Right.
Yeah, so I think that, so in the case of Google, at least last time I checked, it wasn't at all an auction. They'll just say, hey, here's a flat price, but we could preempt you if there is not if they don't have enough capacity. And they also I think, preempt people prophylactically just to make sure that demand is not being cannibalized. So AWS used to have more of an explicit auction. Now it's much more implicit, where you say, hey, here's the maximum I'm willing to pay. They reserve the right to preempt you. They may or may not preempt the guy with the highest price, and so on and so forth. So it's a little complicated. So it smells a little bit like an auction. It's not exactly an auction. Was there another question?
I was just trying to tell you that you have 2 minutes left.
Excellent, and you were wrong. I have 0 minutes left. Oh, there's one more question. Yes.
The last thing you said, the last few things, your description of the cloud computing, it suggests that it's actually not really commodities. There's too much individuation going on. And would that explain why auctions aren't working? I mean, in addition to the other reasons that you put forward.
Yeah. So I think it's a longer question. Let's talk over coffee. But generally, I think it's a lot more of a commodity than a desktop under your desk or that a private data center in your data closet. It is not a commodity or not a perfect commodity in a sense that different public clouds are not perfect substitutes, but within a cloud, if you take a fixed VM type, within that cloud, that fixed VM type is in very significant way a commodity. So I'll end with that, and thank you.
We'll resume in half an hour for Max.